Hi, my name is Deng from Pineview School, and my project is titled Modeling Procrastination-Related Decision Patterns Using an Interactive Narrative Simulation. Procrastination affects millions of students, but most research methods cannot capture how procrastination develops decision by decision as stress accumulates. This creates a clear need for a dynamic computational method. In this video, I will focus on two core hypotheses. First, high delay students exhibit faster escalation and greater instability in their procrastination trajectories. Second, procrastination is primarily driven by hesitation and distraction, while persistence acts as a protective factor. The other questions are addressed through the narrative design and the modeling results. The core innovation of this project is a narrative-based behavioral instrument. It generates real decision data under controlled academic stress. This allows complex behavior to be quantified into four interpretable lane factors, which are hesitation, distraction, persistence, and collaboration. The study involved minimal risk, no personal information was collected, and the experiment was completely anonymous. This simulation uses standardized 14-node branching academic scenario. It generates comparable, decision-level behavioral data under controlled academic stress. This allows us to examine how procrastination trajectories diverge and which factors drive delay development. Each narrative choice is mapped to predefined updates in the four lane factors. These updates are not learned from the data, but defined in advance based on the behavioral meaning of each option. The delay score is then calculated as a cumulative function of these factor changes across the narrative. This design ensures that the model is interpretable and that the results reflect behavioral structure rather than statistical overfitting. Here, you can see the live system in use. Each narrative choice is automatically recorded in real time, with no manual input, ensuring consistent data collection. The system automatically records complete decision-by-decision logs. This includes node choices, timestamps, lane factor updates, and the final model delay score. All data are anonymous, machine-readable, and exported directly for analysis, eliminating manual transcription errors. Here you can see the structured decision-level dataset generated automatically by the system. All records are timestamped, anonymous, and exported without any manual entry, ensuring consistency across participants and making the data suitable for scalable statistical analysis. This figure compares cumulative decision trajectories between high and low delay groups across the 14-node narrative. Each point represents the accumulated decision behavior up to that node, rather than a single isolated choice. This cumulative representation is essential, because in this system, procrastination is modeled as a process that develops over time, not as a single decision outcome. The low delay group shows a steady downward trajectory, indicating consistent action-oriented decisions, while the high delay group remains nearly flat, reflecting repeated hesitation across nodes. The key insight is that procrastination emerges as a cumulative behavioral trajectory shaped by decision structure, rather than a single failure of willpower. This figure shows that all four lane factors change together at the same narrative nodes. This covariation is not a limitation of the model. Instead, it reflects the fact that each narrative node is designed to apply coordinated academic pressure, such as time constraints, ambiguity, or workload imbalance. The aligned factor responses indicate that the narrative structure systematically modulates multiple behavioral dimensions at once, validating the instrument as a system-level behavioral probe rather than a collection of independent measures. Using Jamovi, I tested whether the observed data were consistent with the predefined delay scoring structure, rather than fitting new relationships. These results show that 1. Across the narrative, decision trajectories diverge systematically rather than randomly. 2. High and low procrastination groups separate early and remain distinct. And 3. Multiple lane factors change in parallel, indicating coordinated system-level modulation. In summary, my project shows that procrastination is not a fixed trait or a single moment failure. It emerges through structured sequences of decisions made under academic stress. By using an interactive narrative as a controlled behavioral instrument, my work captures procrastination at the decision level rather than relying on retrospective self-reports. My work reframes procrastination research by providing a scalable, decision-level behavioral modeling framework, and it suggests that understanding procrastination requires modeling the decision-level environments that shape behavior, not just measuring outcomes. And that's the end. Thank you so much for watching.